Hello everyone. Meliorated single image dehazing using dark channel prior with histogram equalization is a major project this year. I am Sirisha representing my group on behalf of Maunika, Deepika, Yamni. We are here to explain what our project is about. Objective. Firstly, it reads the input image and resizes the image size by using pre-processing unit, detects the haze region and estimates the transmission map. Applying dark channel prior technique for target image haze elimination with histogram equalization method, and then calculate the performance by evaluating PSNR, MSE, and entropy values to improve reliability and reduce the computational complexity. Abstract. This paper proposed a fusion of dark channel area technique with histogram equalization to correct contrast and also calculate the performance by evaluating PSNR, MSE, and entropy values to improve the reliability and reduce the computational complexity. Existing methods, haze removal techniques. In haze removal techniques, we have two types, multiple image haze removal technique and single image haze removal technique. In multiple image haze removal technique, we have weather condition based technique, polarization based technique, depth map based technique. In single image haze removal technique, we have contrast maximization technique, independent component analysis, dark channel prior technique, anisotropic diffusion technique. In the brief explanation is given below. This is the proposed method. This is the block diagram of proposed method. The various steps in haze removal process are: firstly, we have to read input image from the given data set. Input image. Hazy images of various locations are considered as input images. Next, pre-processing. The input image is first resized into 512 into 512 dimensions and pre-processed to refine image data by removing undesired distortions and increase spatial visual aspect. Next, haze detection. Hazy regions from the information pictures are extracted by utilizing the dark channel transmission map estimate and atmospheric light estimate. And the next, haze removal. Refined transmission map is obtained using guided filter and refining the atmospheric light. The haze removed image is obtained by recuperating the scene brilliance. The image is then enriched using the contrast enhancement with histogram equalization approach. The next, post-processing. In this step, the image is sharpened to upgrade the edge regions of dehazed image and boost the calibrate of the picture. Performance measures. The PSNR, MSC entropy values are obtained to validate the performance. Dark channel trial. The dark channel trial is a kind of statistics of the haze-free outdoor images. It is based on key observation. Most local patches in haze-free outdoor images contain some pixels which have very low intensities in at least one color channel. Guided filter imaging. Refined transmission map is obtained using guided filter and refining the atmospheric light. The haze removed image is obtained by recuperating the scene brilliance. The image is then enriched using the contrast enhancement with histogram equalization approach. Transmission map. The transmission maps of the input images using the proposed system is seen below. Histogram equalization. Histogram equalization is deployed for image enhancement. The relative frequency of the occurrence of various gray levels is represented by histogram. When a dark image is considered, the pixel values are nearer to 0 or black. When a bright image is considered, pixel values are nearer to 255 or white. As we can see, these are the histogram of pixel values. A represents dark image, B represents bright image, and C represents low contrast image, and D represents high contrast images. So this is the histogram equalized images of the input images using the proposed method. Simulations, existing method simulations. So A column represent original image, B column represent histogram of original image, and C represents output image by existing method. D represents histogram of output image, E represents refined output image by existing method, F represents histogram of refined output image. And this is the proposed method simulations. A represents original image, B represents histogram of original image, C column represents output image by proposed method, D represents histogram of output image, E represents sharpened image of proposed method, F represents histogram of sharpened image. It can be clearly affirmed that haze removal from the input images is more in the proposed method and also provides better image quality similarly for all considered images. Because soft mating is avoided, the proposed approach is faster than the dark channel prior method. Results comparison. Table 1 represents comparing entropy, PSNR and MSE values of existing method and proposed method. Given in an image, the entropy of image reflects how much randomness it has. In other words, how much information it contains. High PSNR and low MSE values are referred to get high definition images. In existing method, the PSNR is low and the MSE is high in existing approach for all images shown in table 1. Conclusion. For the goal of single image dehazing, an unsupervised algorithm method is presented. The proposed method builds on the well-known dark channel prior and enhances it greatly. The existing dark channel prior method focuses on removing haze from hazy images but does not enhance the image contrast. Whereas in the proposed method, the contrast of image is effectively enhanced by using histogram equalization. The proposed solution not only provides cutting-edge performance in outdoor circumstances, but it also effectively decreases the time complexity. Thank you.